Okay.
See?
If I don't have the CC
So-
for borehole 2, then just calculate for borehole 1 and 3.
Well, does borehole 2 show any soft clays?
I think yes.
Yes. So if there's soft clays, it consolidate, right? The problem is just that you don't have the CC values.
Yeah.
So what are you going to do? It still consolidates.
Oh. Wait.
Mm. How now?
Use MV and no, not MV also.
What about your teammates? Any ideas? Got 6 group members, man. Surely someone has an idea, right?
Hello, guys.
Kevin and Tian Am wanted to say something.
Not very sure, sir.
No, sure. Any ideas? Yeah, just put it up there. Just put it out there. Don't worry. Now is the time. No bright ideas.
Huh?
No idea.
No idea.
Cannot be, right?
Huh?
Cannot be no idea. What? Guess. Come on.
Wait.
That's why I wanted everybody to be present first before. I wanted your group mates to be present first before we discuss. So
Okay.
any ideas? You see, borehole 1 you have info. Borehole 3 you have info. Borehole 2 you don't have info. I mean, okay, wait. You borehole 1 and 3 you have the consolidation parameters, but borehole 2 you don't because you didn't do the test. But the thing is that there's soft soil in borehole 3, right?
Yeah.
So and borehole 3, well, borehole 3 indicates soft soil. Now borehole 1 also indicates soft soil. Borehole 2 also indicates soft soil, right?
Oh, you mean can use the same value?
You must have a justification for it now. So go back to the soil profile and see whether the soft layers are connected or not.
You mean
So
the clay layers?
do you have a section? Do you have a profile for borehole 1 to borehole 2?
Yeah, this one.
Okay. So where are your consolidation tests? Where was the consolidation test result obtained from?
Oh, wait.
At which depths? Then
this layer, the clay layer, this one.
Okay.
Anywhere
anywhere else?
Oh, okay. Wait. And this layer. Okay, wait. Yeah, these 2 layers.
Okay. So now look at borehole 2.
Borehole 2?
No, yeah. So no, it's okay. Just that cross section is fine. Now there's a bit of an issue with your cross section. You see, when you plot these soil profiles or these cross sections, remember what your objective is for this assignment. What is this assignment all about?
Wait.
No need to wait. You can tell me now.
Huh?
I don't want to wait. Tell me now.
To determine the
Determine the To do what? What is the whole point of this assignment? What is it about?
Design for the
Sorry?
design for the PVD.
No. Whether PBD or preloading, right? You don't know yet, nah. So you're designing for ground improvement and improvement of soft soils which will consolidate, right? So from this soil profile, where are the soft soils?
Here.
Are you sure? You say clay, it could be hard clay, it could be stiff clay. It doesn't mean soft clay. So the soft, you have to identify, your cross-section shouldn't just show you the different soil types. It should show you the different soil types with different consistency, like whether it's very soft, firm, hard, firm, stiff, or hard. Okay, it's not enough to show. Sorry, Jonathan, go ahead.
Only for the soft clay, the hard one will not.
The hard clays will not consolidate. Firm clay, hard clay, stiff clay will not consolidate. This is a soft clay or soft silt problem. So in your soil profile, you need to identify these soft layers.
Same goes to the firm silt lah.
Correct.
So firm silt also.
So what I'm saying is that your soil profile is not showing enough information. You don't know which layers are consolidating. Just because it says silt or clay doesn't mean that it consolidates.
So you mean need to like layer by layer lah, cannot combine it.
You have to show different shades lah. So let's say clay. If it's very soft, you use light blue. If it's soft, then you use a bit darker. Then if it is firm, darker still. You see, until finally your hard clay is the very dark blue. So same thing with the silt. The silt, you show different shades of green. So from here we can identify which ones are the soft clay and the soft silt layers. You see, because those layers are of interest to you. They are the ones that you're going to be you will need to improve. All right, those are the layers that you need to design for. So you need to identify them so that you can compare where the soft layers are for borehole 1 and borehole 2, right? And then borehole 2 to borehole 3 or whatever your soil profile is. Then from there you can decide, all right, can I use the CC and MV parameters from borehole 1 to borehole 2 or borehole 3 to borehole 2?
You mean they have to be on the same depth, is it? If I use for
okay, roughly.
Oh, okay.
If soil, what if they're not the same depth?
Yeah.
So okay, an example is like this. Now, if you open up your soil profile, okay, you maximize that window. Now let me ask you, okay. By the way, why did you stop the profile at those depths? Like for borehole 2, okay, you got some more below. All right, that's fine. Okay. Now, so if you look at borehole 1, so it goes silt clay, right?
Yeah.
Yeah. So you got green, blue before you have a sand. Now, then borehole 2, you got green, blue, green, then orange, blue, green. All right. Now, what you're trying to do here is so the first layer of silt, you can match it. The next layer of clay, you can match it also. And then the silt, you can kind of match it, but there's a bit of a sand layer. So then after that, what you did is that you match the blue layer. So this in borehole 1 is from about 28 meters to 51 meters of clay to this very thin clay layer on the right for borehole 2. But now, isn't it possible that, okay, isn't it possible that, now, you help me to draw a line here. Okay, I want you to insert one line. Yeah, isn't it possible that from borehole 1, okay, at the bottom of the green layer at about 28 meters, all right, it connects to borehole 2 at 40 meters.
In like this.
Yeah, isn't it possible?
Possible also.
Sorry, Dennis?
Possible also.
Possible also.
Yes, correct. It is also possible, right? Now, you know what? Do you understand the implication of this? From your first soil profile, you see, don't keep scrolling around. I'll just leave it there.
Yeah.
Yeah, from the first soil profile that you drew versus the one that I just asked you to draw, which one has more soft clay or soft silt? The one that you drew, your original drawing, or the one that I asked you to draw?
One you ask us to draw.
Yeah. All right. So that's why even the soil profile has a bit of judgment. So if you look at the sand layer, right, there is no sand layer. There's a sand layer in borehole 2, but there is none in borehole 1. So that sand layer in borehole 2, it may not go all the way like that. What you've drawn is that you try to connect it, but you connect to what? If there's nothing to connect to. So my suggestion is you just draw it like an oval, okay? Just sticking out a little bit halfway through to a bit beyond borehole 2, but it doesn't connect to borehole 1.
You mean somewhere here?
Yeah.
Oh,
Correct.
okay.
Yeah. So same with the clay layer just below the sand.
Is it like need to be triangle or just try to draw?
几粒能啊? Just draw an oval. See?
Something like this.
So something like that. So the top and then the top of the oval, the top of the oval to the bottom of the oval, that's your sand. Then then at the bottom is another layer of another smaller and flatter oval for the clay.
Oh, you mean here is it this layer?
Yes. So in other words, those, because you know the sand layer was only found for borehole 2, but you didn't find it for borehole 1. So why should it connect? And whether it connect all the way, how far it join is anybody's guess. Nobody knows. Correct? So what I'm trying to guide you to do is making conservative judgment by considering more soft layer, right, or more soft soil, even in your soil profile. In your current soil profile, right, what you've drawn, there isn't, it's actually a lot less soft soil compared to what I'm asking you to draw. You understand? Yeah. So what I'm asking you to draw here, right, is more soft soil, which is conservative, because that is also, that means there's more improvement needed.
Right.
Okay. So from here, you'll be able to see whether borehole 1 is connected to borehole 2. So your UD, now when you draw in the UD samples for borehole 1, you can then see, does it apply to borehole 2 or not?
You need to refer back to the soil profile lah.
Yes, you need to refer back to the soil profile to see whether you can use borehole 1 for borehole 2. So you can do the same thing for borehole 3. All right, borehole 2 to borehole 3.
Okay. So I can calculate 3 consolidation for 3 borehole.
Yep.
Do I need to combine them, like get the average on it?
combine and get the average. Ayyo, this one is high school style. Why do you want to do that?
Because
It's like
okay.
it's like it's like Jonathan Jonathan has this much in the bank, and John Arm has this much in the bank, and Kevin got this much. Kevin 1 and Kevin 2 got this much, and then everybody got this much in the bank. Okay lah, I just average everybody get the same amount. Wow, you back check or not? So especially if you have more than everyone else. So Jonathan has 1,000, has 1,000,000 ringgit. Everyone else got 1 ringgit. So we just average lah, huh? Everyone happy, right?
Okay.
You have in geotechnical engineering, the approach is always this. You first start off with available info. If you have data available, use it directly. Okay. If you don't have, then you use as close as possible to the nearest data.
Okay.
If you still don't, then you use the conservative data. Okay, conservative estimate. So
Okay.
now you have your borehole, you have the consolidation test data. Use it.
Okay.
Yeah, it's like, back check, if you got 1 million, if you have your own wallet, right? Why you want to average it, isn't it?
Yes. Okay.
Yeah. So after this assignment, you all go to Jonathan. You ask him to share you all dinner and drinks.
Oh no.
Got money and
and for
now this has a bit more implication now, right? This has a little bit more implication because when you estimate the consolidation, it also means, right, that you will be doing your design of preloading and PVD based on the borehole. You're estimating a consolidation based on borehole data, right? So you go borehole by borehole. So the same thing will happen for your preloading and your PVD. Because once you start off with estimating consolidation, it goes all the way through to preloading and PVD.
Oh, okay.
Okay. Now what this means is, yeah, Jonathan?
You mean the thickness of the field will be different?
The thickness of the field will be the same because the ground level, you just assume the ground level to all be the same. All right. It's all, the top of the borehole is all at 3.1. The ground level that I gave in the assignment outline.
This one?
Yeah, 3.03.
Oh, okay.
So the top of the borehole all 3.03. So the field will be the same.
Okay.
Right. But what I'm saying is that once you start, because your estimation of consolidation is based on borehole. So what you likely do is based on borehole 1, I estimate the consolidation. I then check for preloading. If preloading cannot work, then I design for PVD. So that is borehole 1. Then borehole 2, you're going to do the same. Compute, assess the consolidation, check for preloading. If preloading doesn't work, you go for PVD. So same thing with borehole 3.
Oh,
What this means is that you will end up with 3 different schemes.
Yeah.
Based on borehole 1, you will have one design. Based on borehole 2, you have another design. Based on borehole 3, you have another design.
Yeah.
Okay. So you have to then decide what are you going to do with this. You have 3 different designs. So how are you going to apply them to your site?
You mean like need to adopt the best one, is it?
What is the best one?
Okay.
What is the best one? Then some others will say, we adopt the critical one. What is the critical one? What does critical mean? So what does best mean?
Not sure yet.
Not sure yet. I'm not sure yet. Okay. You find out. You try it out, and then you find out.
Okay. And if I calculating for the borehole 1, then the E0 got a range of value. Which one should I choose then?
E naught is always
Is
the
it-
first value, the initial void ratio at the start of the test.
Oh, how about the CC leh? Also, 0.
No,
The last one.
CC depends on your pressure range. Hey, this is last semester stuff.
Oh, okay. Oh,
Oh,
okay.
I didn't revise, huh?
I better
Don't
revise.
ask me these questions, oh.
Okay.
Don't ask me this question, I will not entertain.
Okay. Same for the CV lah. Okay. I think that's all for my part.
Okay.
Okay.
Any other questions?
No, for me. Just now you already answered.
Already, you're happy with my answers, huh? Okay.
I can feel the answer.
Yes, I have a question. Let me share my screen.
Okay.
Dr. Chu, can you see my screen?
Yep.
For this graph, can we just write the name of the layers inside the graph, or we need to do like put inside a different table like this?
Hang on, you should just go up to the plot again.
This is the SPT and the depth.
Yeah, I think like this is okay lah, but wow, this is overkill, man. It's okay. Yeah. Like this is okay lah.
Oh, so this is just fine.
Yeah, it's fine.
Okay, all right. Yeah, that's all from me.
Wow. Okay. Looks like we're going to finish soon.
Dr. Chu, I have a question. For the
Yes.
diagram just now, does we necessarily need to like differentiate every layer like that, or we just need to differentiate like clear, sand, silt, or like that?
Okay, in the soil profile,
Mm.
it's important to differentiate the soil type as well as the soil consistency. Consistency meaning very soft, firm, clay, firm, stiff, and hard. That is important because you're looking for very soft clays or silts. You see, those are your problem soils. So you need to differentiate the consistency. But for this one, for the SPT plot that that was just shown, that Kevin showed earlier on, like I say, it's overkill lah, but you've already done it, so I don't want to say you don't do lah. So you've already plotted it like that. So for me, I would just plot the soil type lah. So all those details that you plotted in your SPT versus depth, you should actually put it into the soil profile. Then the soil type, just the soil type, right? You should put it into the SPT versus depth.
Oh, okay.
Yeah, because the reason is that the consistency, right, of very soft, firm, stiff, and hard. All this is actually based on SPT.
Mm.
So in the soil profile, you can't see the SPT. It didn't plot it in, right? But in the SPT plot, you can see this. So no need to, no need to show double information. What is important, I think, in the for SPT versus that plot, what you should show is a okay, can you show that plot again, Kevin?
This one?
So I'll give you guys a tip, all right? What you should do is that you draw a line for SPT4. So you have your SPT values at the top, isn't it? So you draw a vertical line, right, that shows SPT4. The reason is that SPT0 is very soft, and then SPT1 to 4 is soft. So it means that any soil or any clay layer or clay or silt layer that is less than SPT4, that one you must design. See, so if you draw in the SPT4 line, a vertical line inside this graph, right, you can very clearly see which layers you need to treat, which layers you need to design for your preload or your PVD. You get what I mean?
Yeah.
So, I mean, one look here is that it's obviously just up to about 9 meters. Okay, so drawing the SPT4 line, it helps.
Okay, I think that's all for my question.
Oh, really? Okay, since no questions from you, then I will ask questions. Is that okay?
Yeah.
Yeah.
Yeah. I've only heard from Dennis, Kevin, and Jonathan. What about Suishan and Tiona?
So,
Any questions?
Hi, Dr. Chu. I have some questions here also.
Let
me share my screen.
Okay.
For the depth we're using, we consider the biggest one like here the 8.5 or we use the average like 8.25.
Either one is okay, honestly speaking. It doesn't matter too much.
Another one is the UND and the RPM here is refers to what?
Very good question. Okay. So do you know what if you look to the just next to it to the left, it says sample type V1. Okay, so do you know what V1 is?
The Vensius test.
So what does the Vensius test give you?
Need to find for the CU.
Exactly, it gives you the CU. So that means you have. So now, when you draw or when you plot CU with depth, there is now one extra. Well, there's another set of data that you have to plot, which is from the vein shear. But it gives you two values. All right. So UND stands for undrained. REM stands for remolded. So in a vein shear test, when you first insert the vein into the ground, you twist it. That is undrained. Then after that, when you twist it again, it's called remolded. So the first time when you not undrained, undisturbed. Yeah, undisturbed. UND stands for undisturbed. So when you first test it, it's the first time you test it, so it's undisturbed. When you test it again, the same one is now kacau already, so it's disturbed or remolded. That's why the strength is lower. So the first time you test it, the strength is higher. The second time, but when you test it again after it has failed, all right, it will obviously be lower. What this means is that, what it means is you are now going to have two strengths. One is the fresh strength, which is the undisturbed strength. The other one is after fail, it only has this much strength left. So so this is going to be very helpful for you when you want to decide on the bearing capacity, or when you want to check the bearing capacity later for preloading
So we obtain the one UND, is it, for CU?
You plot both. You plot both the
Both.
undisturbed and the remolded. Yeah. So your CU, you should have a few. There are many ways to get CU, and you've got your CU equals to 5 times of your SPT. You have a CU equals to 0.2 to 0.25 of your P naught. Then you have your vein shear test as well. You may have some other tests. Right? Some groups may have the triaxial test, so they have to put that in as well. So after have you done that plot?
Not yet.
Not yet. Oh, okay. Then I can't help you.
Okay.
If you have if you have done the plot, you will see that you will need some help in interpreting the plot. So try to do the plot now.
Another one is for on the effective overburden pressure. Need to look at the bulk unit weight and the dry unit weight. But in the data given for borehole 1 and 3, only the data for the bulk density and the dry density are different. So we need to use the U1 or the U2.
Okay. Well, it depends on where your soil is, isn't it? So if it is where was U1 obtained from? So you use the U1 properties. Where is U2 from? So you use the U2 properties.
A bit blur on that.
Okay. So why don't you do this? Now you know where borehole 1, this for borehole 1, right? So you've got borehole 1, U1. Now, are there any other consolidation test results for borehole 1? Is there a borehole 1, U2? Can you scroll down? Okay, so there's a borehole 1, U1, there's a borehole 1, U2 as well. Okay, is there a U3?
No, and only 1 and 2.
Okay, so go to the borehole log now. Go to your borehole, the log for borehole 1.
This one?
I think there might be a bit of a lag. I'm still seeing your consolidation test result. You go to the borehole log, the one that shows the depth and then the SPT and all this.
I mean the very first page, is it?
Yeah, borehole 1. Okay, so this is called a borehole log. All right, LOG, borehole log. So identify where U1 and U2 are. You can just use your highlighter in this Adobe Acrobat Reader, right? And just highlight U1 and U2. Yep. Okay, so U1, if you look, right, U1 is in this layer of very soft clay. So above it, there's also very soft silt. So what it means is that, and then below the very soft clay, you've got a firm layer of silt, isn't it?
Yes.
Then U2, right, is in this soft silt layer. So what it means is that you can use U1 to represent the very soft silt at the top, okay, as well as the very soft clay down to 10 meters. Then you can use U2 to represent the soft silt from 11.5 meters down to, you scroll down to next page. Look. Yeah, down to 19 meters. Okay. Yeah. So this is how you decide. You use U1 for the top layer and U2 for the bottom layer. Okay.
So need to do for both U1 and U2, is it?
Of course lah.
Oh, okay. For the just now about the data for the bulk density and the dry density only given for Boho 1 and 3, didn't have for Boho 2. So need to do for Boho 2 or not?
That's what Jonathan asked me earlier.
Oh, is
So
that-
let me just answer your question with a question. So Boho 2 has soft clay. So Boho 2 has soft clay, but there are no test results. So will the soft clay in Boho 2 still consolidate? Yes or no?
Yes.
Yeah, it will still consolidate. The problem is that you don't have the sort parameters, but it will still consolidate. So you have to do something about it. You cannot say, oh, I didn't test it, therefore I don't need to check for consolidation. Oh, like that's so good. Therefore I don't test anything, then nothing consolidate. So good, right?
Yeah.
Yeah. So you can't do that. So I explained it earlier on how whether you should how to apply, say, Boho 1 to Boho 2 or Boho 3 to Boho 2.
Because the one come into my mind is directly used for the Boho 1.
Why not Boho 3?
Because I just thinking like from Boho 1 to 2, then 2 to 3. So I just think the first one I think is Boho 1.
Oh, but what if I change the numbering? Then? You see, it's got nothing to do. The soul doesn't know what number you gave it. That number is given by you, by the engineer. So you have to check. Like my advice would be to first of all check whether you can apply Boho 1 to Boho 2 and Boho 3 to Boho 2. But let's say like you find out, oh, okay, I can only apply Boho 1 to Boho 2. Boho 3 macam not connected. Okay, fine, straightforward. You just use Boho 1 to Boho 2. But if you find, right, that both Boho 1 and Boho 3, both of them can apply to Boho 2, what do you do? Well, if you don't know the answer to that, you might want to think about it. Okay. So, any other questions?
Yes. Another one is, bulk unit weight, is it same as saturated unit weight?
You can just take it as the saturated unit weight. Yep.
And okay, the last one is about the question that we have asked yesterday about the moisture content only for U1 and U2. So the graph that I plot, it's look like this.
I think you've got to reshare your screen because I only see your Adobe Acrobat Reader.
So the graph that I plot is look like this. So is it correct?
Well, there's not much that you can. I mean, the plots are not correct because depth should always be vertically downwards. Okay.
Oh, you mean
And
from zero
the
here
moisture
then to-
content, yes, correct. From 0 is at the top, and then and it increases downwards. Then you should the plot on the left, on the horizontal axis, it should start from 0, not 48,
Okay.
right?
So the point that only these 2 points is correct lah. The
Yeah,
vertical
based on
and
the
the
data that you
horizontal
have,
is not.
based on the
Oh,
data that you have is correct, of course. So, but more importantly is so what?
Okay. That's all for mine.
Okay.
Total 2, I got one question.
Okay.
Seamus. Can you see my screen?
Yes.
So, just now you say that the important one is the soft or dense or firm or hard. So can I just combine this very soft brown clay and very soft gray, slightly sandy clay together to very soft
Yes,
clay?
you can.
Oh,
Yes, you can. The color of the clay not important now, honestly lah. For the geotechnical engineer, I don't care about the color lah.
Okay.
So yeah, more important is the strength, you see, and whether it's soft or very soft or firm, that is more important.
Okay. Thank you. That's all.
Oh, okay. All right. Now, since no more questions, and I will ask a question. So, when you complete your consolidation, Jonathan, could you share your that page or that document, right, where you're calculating the consolidation based on CC method?
You mean the word file just now?
Yes, just share it on the screen.
Okay. This one?
No. So your consolidation equals to CC01 plus E naught H, then log of the P naught plus delta P divided by P naught. Now that delta P is the permanent load. You have said there that it is the field layer. So is everybody clear about this one? About that comment that he has made? He said he has stated at the bottom there that delta PP equals to field layer only. The building sulfate transfer through piles.
Got wrong?
No, I'm asking, is everyone clear on this? That's my question.
The sulfate of building is transferred through pile to the firm stand at the below. So the surface layer don't have the weight.
Are you clear on this? Because you must know how to explain this. There's a reason, right, that the permanent load is the field layer only.
Oh, okay.
Yeah, so when you state this,
this one is because the software will transfer through the piles to the firm layer below, right? It will bypass the soft layer.
yes, also it will bypass the soft layer, meaning, right, that the building's weight is not transferred to the soft layer. All right,
Only
so it will not, only the field.
Okay.
So when you calculate your PP later, when that delta P in your equation should be the field layer only. And the same thing goes for your preloading.
Oh, okay.
Okay. All right. If nothing else, that's all
That's all.
from me.
Okay. Can I ask something about tutorial?
Okay.
for this question, this micro refers to the micro not or the micro one.
Poisson's ratio. It
Oh, this
refers
one
to Poisson's ratio.
Oh, okay. Okay.
Yeah.
Wait, and for question 4.8.
Yep.
For the driven pile, is it just the Q shaft plus the Q base? Because I calculate the value got slightly different from the answer.
Okay, let me have a look.
Okay.
Calculate the ultimate gross load. Yeah, show me the question. Okay. 'Give me a minute. Let me look.
Okay.
4.8. .8. Right. Let me see. So for board pile, that answer that you have, the one on the that 1432. Is that the answer?
This is what I calculated. Based on the calculation,
Okay.
the Q shaft should be this one.
Yeah, 5996 is correct. So for driven power, and then the Q shaft is yes 1472 for driven power also.
No, this one is I copy from the answer. This one. This is my answer.
The answer is 1432. Yeah, I wanted to check with this whether that 1472 is the given answer.
Okay.
Okay. Now let me see. Your calculation is for driven power, right?
On the left side is for the board for the board pile. Then for the driven piles, I only calculate for the shaft because I think.
Okay. Can you zoom in a little bit? Because your handwriting is quite small. Okay. So for Q shaft, now let me just check. Okay, I think it's just the alpha value that you've chosen. Okay.
Okay.
So yeah, so the alpha value that you've used is 0.7. But if you use 0.72, you'll find that you should get 1472.
Oh, okay.
Yeah.
So for
So yeah.
okay. So for both piles, they always only got the base, the Q base only, right? For both pile.
Yeah, in this case, it's just a Q base only.
Okay.
So the Q base that you should be getting is a 4-5. Yep, 4-5-2-4. That's correct.
Okay.
Also, but let me just tell you that in practice, we usually neglect the base capacity for ball power. Okay, in practice, especially for our rocks here. The rocks here in Kuching and Sarawak, they tend to be quite weathered. So we usually don't include the Q base for ball piles. The reason is that you may not have a good contact between the base of the pile and the rocks. It may not be intact rock. It may be crushed rock at just below the pile base. So the Q base that you calculated may be overestimated. So we usually don't consider it.
Oh, you mean don't consider the Q base for board pile?
For ball piles, yeah, usually there are ways to do it. There are ways to consider it.
But
Okay,
what
there
if
are.
but what if don't consider it? Then the Q will be 0, is it?
No, you have Q shaft. So there's also a Q shaft for the rock. There's also that.
Okay. But just for this, in this case, don't have for board pile.
Yeah, correct. So in your case, there isn't one. So never mind. It's fine. Okay.
Okay.
Yeah.
Okay. And for 4.10, the Young modulus for the soil is not given. Should we get from online? Because I think I can't find in lecture slide.
If I remember, there should be a slide showing you for CU of 30 of so much. Then the E is. Let me check for the sort. Yeah, I remember that there was one page in your notes for
you mean
given
the
CU the E. Yeah.
okay.
If you look back at your notes, I remember that there was one slide.
In chapter 4?
Yes, chapter 4. Single power.
Is it the last slide in slide 4D?
Hang on, looking.
Okay.
Yeah, that's the one.
Okay.
The second last slide, yeah.
Okay. And for this one, the Meyerhof method, why is it the data value used is different?
Meyerhof method?
Yeah, because for in the canvas you stated need to use the 40, but for calculating this 6701, when we use the 38.5, then the answer is correct. But if we use 40, then we'll be wrong.
Oh, okay. It's fine. Just use according to the value that is given in your in the question.
Oh, okay. So if
So
the,
yeah, just use this. Yep.
oh, so if there are two values, then we just use the bigger one, is it?
No. You see, this is for Q base, right?
Oh,
So your
yeah.
base is in the dense sand. So you use the dense sand value.
Oh, so use 40 for all lah. Okay.
For the yes, you use 40 for the base.
Okay.
Yeah, for the shaft, then it's different. The shaft will be you're using this method on the right.
Dr. Chu, can you check what is the error here? Because I tried calculator a few times, but the answer is still different.
Yeah. What was the question number again?
4.6.
Okay. Yeah. So what should the answer be?
1, 3, add 2.
One three eight two. Okay. So I've got the solution here, but I'm trying to draw it out.
Is this distribution diagram correct? This one.
No, so just give me a minute because I need to
Okay.
just look at the calculation for a while.
Okay, sure.
Okay, all right. Okay, I will flash up on the screen what the solution is.
Oh, you mean you share screen?
Yeah, I'll share my screen.
Oh, okay, sure.
Now, so you just focus on, we start off from here, okay? So this one is the F and the ZL, the limiting depth values depending on the sand, okay? So then if this is for the top 7 meters, then this is the dense sand from 7 to 15 meters. So the calculation of the limiting depth is 2.4 and then 4.5. So from here, right, this 0 to 2.4, it increases linearly up to 2.4 meters, and then it becomes 24 kPa. Then after that, right, from 24, it doesn't become 24 kPa. It is the overall F, okay, the overall F, because here, right, you see they divided by 2. So in fact, it is the limiting depth. It's just that it's increasing from 0 to 48.
Okay.
Okay, so it's like let me just draw it. Hey, where is the annotation? I'll comment. So it's something. Yeah, it's like this. So this is F. Okay, and this is depth. So the top is 2.4 meters. Okay, down up to 2.4 lah. Okay, it will increase with depth linearly up to a value of 48. Okay, but the calculation here is actually the area under the triangle lah.
Okay.
Yeah, so that's why it's 24 divided by 2. You see this divided by 2 over here.
Mm.
Then after that, it stays at 48 until a depth of 7 meters. Then after that, so when it gets to beyond 7 meters, it will jump up, okay, to 148.5. It will jump up to 148.5. Then after that, it stays like that. So why is it that it is this distribution and not the one that you drew? The reason is because of this. Okay, 4.5 meters. The dense sand is already at a depth of 7 meters, so it's already beyond the limiting depth. Yeah, so it's already at the limit, so it just jumps straight up to 148.5.
Right. The 4.5 meters should start from the ground level, is it?
Yes. Yes,
okay.
that's right. It doesn't start from here. I know what you mean. That it should actually, because it should start from here. So from 48 to 148.5. If you try to find out what is that limiting, what is the rate of increase, then it should be less than 4.5 meters, but starting from 7. So 7 plus another, say 2 meters or 3 meters. All right. So depending on how you linearly interpolate between these two values. But the idea, the thinking here, right, is that this 7 meters is already below the 4.5. It's deeper than 4.5 meters. So it's already at the limiting value.
Oh, okay.
Mm.
Okay.
Also, so the distribution is like that. Okay.
Okay.
All right.
Okay. I share back my screen. One more question.
Okay. Okay.
Wait. This one. For 4.14, the question got give an answer for Q gross allowable, which is 60.4 kilonewton. If do not apply factor of safety to the negative component, should it be the answer is based on this, but I think is a little bit weird. Is this the correct one?
This is question 414, is it?
Yeah.
Okay. Well, could you show me the question? Okay, calculate the ultimate gross capacity. Okay. So this is NSF. Fuels consolidating. Okay. Calculate the gross safe. This is gross. Okay. Gross. The gross safe working load. So now you have calculated, you have used the net. It shouldn't be net.
You mean this one?
Yeah, because it's asking for the gross.
Oh. I thought if divide by the gross divide by the factor of safety will give us the net.
No.
Okay.
I see. Yeah. net gross minus the self weight of the power will give you the net.
Oh, oh
Okay.
yeah. Okay.
Yeah, so gross divided by ultimate. So be careful how there's the word in the
Oh.
bracket is
Oh, yeah.
and the ultimate or allowable they are different things. So
Oh.
what is this 75.4
This is the negative shaft resistance.
skin friction? Okay.
Yeah.
Okay. All right. Yeah, that's correct. So 75.4 is correct. Your Q shaft 326.7 is also correct. Okay, so the gross is not the 326.72. So what about your Q base?
30.68.
Okay, that's correct. Yeah.
Okay.
So the Q ultimate gross is just simply 407.4 divided by 3. That's the answer, 135.8.
Oh, okay. Just write wrong lah.
Yeah, lah. It should
but
be
this-
Q allowable gross now.
Oh, okay. But how the question get this one leh? A bit confused by the equation. This one.
Sorry, what is this? 407.4 minus 75.4. What is that?
This one is if they do not apply the factor of safety to the skin friction.
Oh, okay. Yeah, because when you apply the factor of safety, right? You notice that when you what you did here is that you took the Q shaft, you calculate the Q shaft as the Q ultimate shaft minus Q skin friction, the negative skin friction. So when you divide by 3 like that, you actually applying a factor of safety of 3 to the NSF as well. But the issue here, right, is that the factor of safety should be applied to the resistance, which is your Q shaft and your Q base. Your NSF is not a resistance. Your NSF is a load.
Okay.
Yeah.
Mm.
So you should not be applying the factor of safety. That's what they mean.
Okay.
So in other words, the factor. In other words, right. The other approach is this: your Q ultimate shaft, no, your Q allowable shaft is actually 402.1 divided by 3 minus 75.4.
Oh. Wait lah. 0.2.
Yeah,
Okay.
402.1. Okay, divided by 3 minus 75.4. In other words, 75.4 you do not divide it by 3. You don't apply a factor of safety to 75.4.
How about this one then? The Q base don't need to include.
That one you apply a factor of safety because it is a resistance.
So you mean this one is correct?
Yes, that one is correct.
Oh, so this one is wrong lah.
Mm.
Oh, okay.
Yeah, but I don't know what your 407.4 is. I see what you mean. 407.4 is the total gross.
Yeah.
You can't do this because okay, to get your 407.4 is actually your Q shaft minus NSF then plus Q base. So it's very funny, right? That means 407.4 divided by 3 minus 75.4. That is actually Q shaft minus NSF plus Q base divided by 3, then minus NSF again. The NSF is minus twice.
You mean this one, huh?
Yeah, that's why it's wrong.
This one
NSF minus twice.
we derive from the answer. Okay.
Yeah, this one is wrong. So the
okay.
NSF minus twice is a bit overkill.
Okay. So this one is correct this way.
Yes, correct.
Okay. I think no more question.
Okay.
All right. Thank you, Dr. Chu.
All right. Thanks, everyone. Bye.
Good, Dr. Chu.
Bye-bye.
Thank you, Dr. Chu.
Thank you.